Hello and Assalamu alaikum. All praise is to Almighty Allah. My name is Anwar Ahmed Siddiqui and I have two mates also. In this tutorial, we will share you application of numerical analysis in real life problems. At the end of our tutorial, you will able to know how to use numerical method in mathematics, numerical method in time prediction, numerical method in engineering, and finally numerical method in some real life problems. As we are a student of mathematics, our first priority is mathematics. If we focus on some system of linear equations, we'll say there are some system of linear equation which have two equations with two unknowns. We can solve it very easily. But what to do if we have 100 equations in 100 unknowns? No problems. We have some methods for solving system of linear equations. Number one, Gauss elimination. Number two, Gauss-Jordan elimination. And number three, Krauss reduction method. Now, if we focus on nonlinear equations, we'll say there are some simple quadratic equation can be solved analytically as shown as the sprint x square plus 4x plus 3 is equal to 0, which analytical roots are x is equal to -1 and x is equal to -3. But many other equations have no analytical solution. What to do if we have nonlinear equation which have a degree of more than 3, 4, 5 or more? We have some method for solving this kind of nonlinear equations. Number one, bisection method. Number two, Newton-Raphson method. And number three, second method. And if we focus on integration, we will say there are some simple functions can be integrated analytically. But many other functions have no analytical solution, like integration of e to the power minus x squared dx. We have some method for solving all kinds of numerical integration. Number one, Simpson method. Number two, trapezoidal method. And number three, Wedel's method. Now, there are some methods for solving ordinary differential equations, which are initial value problem. These are Runge-Kutha method, Adam-Milton character method, and Milnes character method. There are some methods for solving ordinary differential equations which are boundary value problem. Number one, finite difference method, and number two, shooting method, and finally number three, weighted residual method. Now I welcome to our mates Munir Shafin to continue our time prediction and engineering slide.
Thank you, Faisal Siddiqui, for giving me such opportunity to represent the wonderful slide. At first, I welcome all of you who are listening to me with the Islamic greetings. Assalamu alaikum wa rahmatullahi wa barakatuh. May the peace, mercy, and blessing of Allah subhanahu wa ta'ala be on all of you. By the name of Allah, we will begin the middle session of our tutorial. In this session, we show the application of numerical method in two sectors. The first is crime detection and the second is engineering sector. Now we will focus the crime detection. To visualize this, we take a short crime history where Munir is a robber. He robs a bank and escapes in a getaway car. At the same time, he persists by police. It's a good news that the police take a photo of that car, but it's a matter of truth that the photo is blurred. We want the distinct photo or clear photo of that blurring photo, and it's our main attention. But how can it's possible? Okay. At first, we take a model of the blurring process and blurring function g for the original function f, and blurring formula like this, which is shown in the screen. Inverting the formula, we can read the blur, but we need to know the blurring function g and a formula which is shown in the screen. By using Simpson's method or trapezoidal method or Rule's method, we can solve this problem or this equation and find out the blurring function, from where that we can get the distinct photo or clear photo of the blurring photo of that car. And using this, the police can catch the robber. Okay, I hope that all of you understood this wonderful application of numerical method. Now we will try to show the application of numerical method in engineering sector. We show some basic steps, and that is the basic algorithm to solve a problem in engineering sector. Actually, a engineer at first take a problem description, and the second step they create a mathematical model or problem, and the third step they solve their mathematical problem, and finally use the solution or use their solution. And this is the basic process to solve a numerical problem or to solve a engineer problem. But where are the numerical method which is used here? This is third step. To solve their method, they use numerical method. Please turn over the next slide. Let us take an example, that is how much of the ball is underwater if the diameter is 0.11 meter and its specific gravity is 0.6. How can we solve this problem? Okay, please turn over the next slide. At first, we take a problem description, what is given data and diameter and specific gravity and what to find. And the second step, we will create a mathematical model or mathematical problem by using simple principle of fluid mechanics. And we take a cubic equation like this, which is shown in the screen. By using Newton-Raphson method, we can find out the solution of that problem or the cubic equation, and which is the raw materials or primary raw materials of the engineering sector. And they use this solution to solve their other problem. Okay, I hope that all of you understand this application of numerical method in engineering sector. Now I welcome Sharia Jewel to continue the next portion of our tutorial. Thank you.
Thank you, Monir, for giving me the platform to present the numerical methods. Hope you are doing well, and assalamu alaikum. Now let's move on to the tutorial. My PCWords team members have shown you so far the several aspects of application of numerical methods. Now in the part, I will show you some real life problem in numerical methods. So serving the purpose, I will take two examples. So first one is, as you can see in the screen, so I can read it. The vertical distance covered by the rocket from time t equals to 8 to time t equals to 13 seconds is, if its velocity is given by, as you can see, the velocity is given. So solving the maths, we can take the integration with time with respect to time t and limit 8 to 30, we'll get the result. But if we solve the math with the conventional way, which is very tough to solve. So if we solve in a very minimal way, which can be solved by numerical methods, and these are Ödel's methods, Simpson methods, or trapezoidal methods. So we can solve with that. And the next example is, the next example is you can see in the screen. We are given a ball whose initial temperature is 1000 Kelvin, and we are asked to find out ball's temperature after 500 seconds. If the ball is cooled down in the air and ambient temperature of 300 Kelvin. So we saw the solution. If we solve the problem, there is sophisticated tools of numerical method, which is runs to the methods of order 4 to solve this problem. Here mentioned formula is theta I plus 1 is equals to theta I plus 1 over 6 into K1 plus 2K2 plus 2K3 plus K4 into H, where the value of K1, K2, K3, K4 are given, and there is the equation of temperature of balls is given by which seen in this frame. Yeah. If to solve the problem, we take two steps. In the first step, the step size is 250 seconds by using formula and the parameter where I equals to 0, T naught equals to 0, theta equals to 100,000 Kelvin. We get the value of K1, K2, K3, K4 as you see in this frame. And finally, using all those equation and all those things, we get the result. Theta 1 is equals to 714.75414 Kelvin. And the next part is where H is equals to 500 seconds, the final steps, and the parameter are I equals to 1, T1 equals to 250 seconds, and theta 1, which we got from the previous step, is 714.75414 Kelvin, and we get the value of K1, K2, K3, K4, and the theta 2, where the value is 613.785858 Kelvin. So finally we get the temperature, which is after 500 seconds, the temperature of the ball is 613.7858 Kelvin. Here you can see we are the team members who belong to Chittagong University Department of Mathematics, and that officially conclude our presentation. But the reference we take for making tutorial, including two books named Numerical Methods for Scientists and Engineering, authored by K. Sundara Rao, and another book is Numerical Analysis by A.R. Batista and Bipin Basista, and also the internet and Google. And lastly, we want to dedicate our tutorial to our veteran late Postmaster Safiul Alam Tarafdar, whom we have lost in the corona pandemic. We want to pay our deep homage towards his departed soul and solicit to Almighty Allah to offer him the pinnacle of Jannah. And that's it. That conclude our tutorial. Hope you understood all the pages which we have shown you. Thank you all.